Hi, welcome to this episode of the Data Beat. My name is Puneet Sachdeva and today I will talk about as to how a Web 3.0 technology is powering Azure SQL Database. I will cover how decentralized ledger is making data in Azure SQL verifiable. I had briefly covered this in my last week's video wherein I shared the latest updates from the MS Build 2022, and this topic definitely intrigued me to explore and share it with you all. As the host of the Data Beat, my aim is to bring the latest from the world of data analytics. Like always, it's a good idea to like the video, subscribe to the channel, and click the bell icon to get notified about the new shows. Before we get to understand how Ledger is being used in Azure SQL Database, it is important to understand what it is and how it is revolutionizing the world and making things verifiable. Well, if you're of my age, you will definitely remember the time when you used to play a game called the trump cards, or some of you may know it as flashcards. Usually, the game was played over a considerable longer period, maybe several hours to days and sometimes weeks. And in this game, people used to borrow, win, steal cards that they deemed strong compared to their opponents. Now, players tend to manipulate the progress of the game if it is spanned, for a considerable longer period. And to address this lack of trust, the progress of the game, including the major cards and the related points, were basically written on multiple sheets of paper. One paper or one sheet for each player, and all players kept it with them while the play was at halt and confirmed the start point for the next session. Now, when I see and look back, the way we used to handle the situation related to this maintained trust or lack of trust, it has not changed much in principle. Today, implementing a blockchain helps achieve trust by keeping a ledger of transactions, where a group of transactions forms a block, and the block, after a certain number of transactions over a time period, is committed to the blockchain. And just like the old days, the ledger is decentralized. That is, it is not maintained centrally, rather, all the actors keep a copy of it, and any of the actors can verify the sanctity of the transactions. Now, applications of blockchain are endless, and the most popular applications, as we all know, are cryptocurrencies. Let's understand the basic underlying principles of implementation of a blockchain or decentralized ledger before we could frame it in the context of the Azure SQL database. A blockchain is a distributed database, meaning that the storage devices for the database are not all connected to a common processor. It maintains a growing list of ordered records called blocks, and each block has a timestamp and a link to a previous block. So whenever set of transactions get accumulated, they get merged in a block, and this block actually gets committed to a blockchain. So users can only edit the parts of the blockchain that they own by possessing the private keys necessary to write to the file. Now cryptography has a major role to play in this. It ensures that everyone's copy of the distributed blockchain is kept in sync. It is this design, which includes decentralization and cryptography, makes the blockchain secure and suitable for almost all scenarios where trust needs to be implemented. Now, we have talked about the blockchain, but how does this apply to a SQL database? Microsoft has implemented Ledger in Azure SQL Database, which cryptographically verifies the data and its integrity, which means that the data in the database with Ledger enabled cannot be tampered with and can only be created or modified by trusted applications and users. And whenever a non-trusted entity makes a change, you will be able to verify it and pinpoint who did it. To achieve this, besides the historical data, an immutable cryptographic digest is persisted. The digest represents the overall state of the ledger, and it can be stored in external storage, thereby separating the database and provides a secondary level of protection from any attacker or any high privileged user, including the DBAs or cloud administrators. A similar concept was implemented in the blockchain. While blockchain solutions aim for full integrity, the SQL Ledger implemented in Azure SQL implements what is called as a forward integrity. Now, coming to the SQL Ledger architecture, there are several components to it. It involves the use of ledger tables at the center, which are designed to protect the integrity of the underlying data without requiring any application changes. Ledger tables are just another relational table with an additional capability to allow users to detect the malicious data modifications and cryptographically verify the data integrity. Other type is updatable tables, which allow all operations and can be used as regular tables by any SQL application. The earlier versions of a row are preserved in what is called a history table. For every ledger table, the system automatically generates a view called the ledger view, which leverages the history table to provide the historical changes. In order to track the changes, each row is accompanied by what is called as the ID of the transaction. And there is also a metadata stored for each transaction. All of this helps maintain and identify the time the user who executed it and correlate with the operations performed by this operation. It is this transaction info and the metadata which is stored in the database ledger. The hash of the latest block in the database ledger is known as the database digest, and hence it represents the state of all ledger tables in the database at the time when the block was generated. This allows the users to extract a digest and use it for verifying the data integrity in the complete database. Internally, the digest is stored as a JSON document that contains the hash of the latest block together with the metadata regarding the block ID, the time the digest was generated, and the commit timestamp of the last transaction in the block. Well, SQL Ledger cannot prevent editing the database rows. Rather, it can detect any tampering when the ledger data is verified. Ledger verification process takes as input one or more previously generated database digests and computes all the hashes stored in the database ledger based on the current state of the ledger tables. The process scans all ledger and history tables and recomputes the cryptographic hash for their rows to verify the digests stored in the database ledger. Now that's a handful, and as you see, this is a resource intensive process, and it is expected to be executed only when the users need to verify the data integrity. SQL Ledger in Azure SQL Database is just the first step. At the moment, it looks appropriate for the systems of records or where financials or asset related transactions are being maintained. Nevertheless, this will have its own benefits implemented for systems which maintain the single version of the truth, such as Azure Synapse Analytics, wherein you have this Azure Synapse SQL Data Warehouse to where the single version of the truths are being maintained for several downstream systems. If you would like to know more, I came across a white paper published by Microsoft on this topic. Please see the description for the link in the video. So that's it for this episode. I tried to share as to how Decentralized Ledger is powering Azure SQL Database and making the data verifiable, just like how it is done in the blockchain. Feel free to reach out to me through your comments. I'm eager to learn from your experience and as well as share mine with you. My intent is to simplify the concepts and bring them to you. If this helped you to build some understanding, then I think it's a good idea to like the video, subscribe to the channel, and share it on LinkedIn or wherever your peer group is. So until we meet next time, keep the beat flowing.